Aloha and welcome. In this video, we're going to be talking about authentication by way of biometrics. So this is something that used to be kind of outside of the realm of what we could imagine, but now we can see that our phone has this technology in it. Some of our keyboards have this technology in it. So let's go ahead and dive right in. So we're going to open up our textbooks here, and we're looking here at section 2.4, authentication biometrics. So biometrics are the measurements of the unique characteristics of an individual. So examples of that are fingerprints and voices. And there's two different types of these biometrics that exist. One is physical and the other is behavioral. So physical you can think of as kind of things that are characteristics of yourself, like your fingerprints, your palm print, your face, your retina, your iris, and the vein patterns. So vein patterns is kind of freaky. I've never heard of vein patterns being used, but that's also a thing now. So behavioral biometrics, that's going to be a little bit different, and that's going to be using like your voice. I've heard of voice, pattern. When you call in for certain phone services, they may say, say this phrase in order to, they'll have you say a certain phrase. And then when you call back in, instead of verifying account information, they can just tell by your voice what exactly, or who, they can authenticate you just through your voice. So that's kind of cool. There's gait, which is the way you walk. I don't know how exactly you're going to do that for an authentication method. If you think about it, what's it going to say? Back up from the thing and walk around, sashay across the red carpet and see, show us your strut. I don't know how you do that, but supposedly there is a way to look at one's gait and figure out how exactly, or who exactly you are. So great for that. I have never seen it, never heard of it. I look forward to seeing it in the future. Then there's also signature, the way that you write your signature, and there's also keystroke as well, because when you're typing keys and everything else, you have a certain cadence of doing that, and that is behavioral. So they can use that type of behavioral biometrics. There's different accuracies for these things, obviously, because some things are going to be a little bit better than others, and we'll get into that in just a minute. But just know that it divides down to physical, which is the things that are you, the inherent things, and then there's going to be the things that are behavioral. So we've got a chart here, shows biometrics breaking up into physical and behavioral. It shows you the things like face, hand, vein, eye, DNA, and tells you, like, for eye, we've got retina and iris, and for hand, we've got fingerprint and palm print. And then under behavioral, we've got voice, gait, signature, keystroke. So here it's just going to have you match up different things. Down below, it's going to talk about biometric authentication. It's an authentication method that uses your physical and your behavioral biometrics to verify claimed identity. Biometric authentication is more secure than knowledge or token-based authentication. So password or PIN, they can be shared, it can be guessed. Tokens can be lost or stolen, but biometrics are unique to an individual and can't be transferred, lost, or forgotten. So biometric is nearly impossible to duplicate. So that's the nice thing. Regardless of the movies that you've seen of people like taking, fingers of a body and putting it on the thing, or an eye, something like that, it's very, very difficult to duplicate. So here we have some more matching participation activities. Biometric factors, this is where it starts to get really cool. So biometric factors, also known as inherence factor, because it's inherently you. It is naturally, you, your body, things like that. It's unique physical and behavioral characteristics of an individual. So biometric factor is something you are. We talked about that for the different things. We've got something you are, something you know, something you possess, things like that. This is the something you are. And there's 7 biometric factors that we're going to be talking about here. We're talking about fingerprints, the patterns and ridges and values of an individual's finger. A finger is scanned using ultrasonic, optical, and capacitive scanners. I had to go through fingerprinting just to teach this class, which was my second time in as many months probably, because I had to get fingerprinted to work on a federal grant over the summer teaching cybersecurity. So they take your fingerprints and research you that way. Retina, you can do a retina scan. So retina is the layer of nerve cells lining the back of your eye. So know the difference between your retina and your iris here. Got to get into the science here. But a retina, it's the layer of nerves lining the back of the eye. So a retinal pattern is the blood vessel pattern in your eye, basically in your retina. So retina is scanned using low energy infrared light. So we also have iris scanning. So iris is the colored portion of an eye that surrounds your pupil. So an iris pattern is the pattern of an individual's iris. So an iris is scanned using a video camera technology. Then we've got facial recognition. Facial recognition is pretty complex, involves the measuring the distance between different points on your face to create this thing called a face print. So face print is a digitally recorded representation of your face. And the measurements may include like the jaw line, the shape of the cheekbones, the width of your nose. So a video, infrared, or thermal camera can be used to scan your face. Voice recognition, it uses a microphone to measure and analyze the rhythms, the patterns, the sounds of an individual's voice. And then we've got vein recognition. So vein recognition uses an infrared light scanner to capture and analyze an individual's blood vessel patterns. So unlike a fingerprint scanner, a vein scanner does not have to be in contact with your skin. Then we've got gait. Talked about gait before. Gait is an individual's walking pattern. So gait analysis is a study of an individual's movement and muscle activity during motion. My guess, aside from the funny comments before, was perhaps they can see you on a security camera and use that information to verify who you are before you get to an actual point. Um, and then here we have matching up, iris, fingerprint, gait, retina, faceprint. Remember, you need to know the difference between your retina and iris. Remember, the retina is the back of the eye, the iris is surrounding your pupil. And over here, we're just going to match up, which ones fit the explanation. Now, biometric errors, as I mentioned before, different methods of biometric analysis or authentication have different rates of success. So the things you have to worry about is your false rejection rate, or what they call a FRR or type 1 error. Then you've got the false acceptance rate, which is FAR or type 2 error. Then you've got the crossover error rate, the CER. That's known as your equal error rate. That's when you've got both your FR and your FAR equal. So the way these are calculated is your false rejection rate. That's going to be the percentage of valid biometric measures that are rejected by the system. So then you've got your false acceptance rate. That's going to be the percentage of the invalid biometric measures that are accepted by a biometric system. And the crossover rate is just where they're equal. So if you think of that false rejection, that's going to be we've heard of false rejections and false acceptances before in other types of things. So this is essentially it's the same thing. You don't want it to accept things that aren't true, and you don't want it to reject things that are valid. So that's what we have to be careful of. So the effectiveness or efficacy. Efficacy, just think of as effectiveness of a biometric system. It's going to be the measure of the system's ability to minimize the false acceptance and prevent the false rejection. So the FIDO Alliance, which is the alliance that certifies biometric systems, they've established that you want your false rejection rate threshold of 3%. In other words, 3 out of 100 for the false rejection rate. So they only want the inconvenience of 3 people being tossed that were actually valid. But on the other side, they want a false acceptance threshold of 0.01%. So that means that 1 in every 10,000 people will get through the system. So if you look at that, that's still a large number when you think about it, but it's considered the acceptable error rate right there. So then you get into matching up your terms here, and we get down into a nice graph here that shows us the relationship between false acceptance rate, false rejection rate, and the crossover error rate. So as the likelihood of a false rejection rate, so this is your false rejection rate here. So as this is decreased, the rate of the false acceptance rate is increased, okay? So as this is decreased, you're going to see this is rising. So as this goes down, this goes up. So you see your rejection rate is going down, and that stands to reason, because as your rejections are going down, it's being a little bit more accepting. So you're going to expect that the false acceptances would rise as this is going down. Also inversely here, as the false acceptance rate is going down, going down, you're expecting that the false rejection rate is going to be going up. Okay? Think about that for a few minutes. Think about what that means. Take a look at it, and you can run this animation and it'll show you that visually as well. So the relative operating characteristic, the ROC graph, this is the ROC graph here. This is a visual characterization of the trade-offs between FRR and FAR. On an ROC map, the CER is the point where the two intersect down here. Okay, so CER is used to compare the accuracy of the different biometric systems. So when you're looking at fingerprint versus voice versus whatever, you want to get the one with the lowest CER. That's going to be the more quote unquote accurate one. So the biometric system with the lowest CER is the most accurate. So let's start looking at this the animation here. So we're seeing the false rejection rate here. So the FR increases as the biometric system sensitivity increases, okay? So as it gets more sensitive, it's going to be rejecting more, okay? So it's going to reject more. So the biometric the false acceptance rate is going to go down as you increase your sensitivity. So as it gets more and more sensitive, the number of acceptances is going to go down and the number of rejections is going to go up. Okay, so that's the way to think about that. So the crossover error rate right here is where the two intersect or crossover. So the CER is the rate in which both of them are equal. So then we go over here to our participation activities. We're looking at answering, which ones they are. This is really important because this is going to dig into your understanding of what those relationships are. So go ahead, spend some time in here. It's worthwhile. Then we have challenge activities. The challenge activities are going to wrap up everything that we've had there. So you're going to go through here and you're going to choose, like for here, what is the biometric type of each biometric factor. The nice thing about this, you miss one, it's going to have you do it over again with slightly different ones. So, and once you've finished all four, you can go back and click on other ones. It'll generate a new set of things for you to try out. So you can keep on testing your knowledge that way. And that is it for the biometric authentication methods. Again, if you have any questions, reach out to me, jsj3@hawaii.edu. I'm happy to answer any questions you might have. Other than that, have yourself a great day, and I'll see you in the next video. Aloha.